And I think we're here. Maybe? Possibly. If this is working, that'll be really cool. So, good morning to everybody. Hopefully you can both see me and hear me. And that will be amazing if that... Oh, cool. Thanks, Larry. So right before the stream, I've been stuffing around with a new camera setup. What you're looking at right now, hopefully, is my old Canon not a webcam, it's a handy cam. One of those things you put cassettes into, like video tapes, and then you record things. That was my main camera for a very long time. I did many of the early SuperHouse videos using this camera, and then I switched to the Panasonic camera. So what I did was I pulled that out, and I've got a really dodgy long HDMI lead which is running all the way along, and it's plugged into the game capture device which is attached to my microscope. So I'm feeding from the microscope then, well, the game capture, back into my computer and then taking the video that way, which is kind of dodgy, and if I move this cable the video cuts in and out, but it seems to be working at the moment, and I think the video quality on it is quite a lot better than the built-in webcam. So just as a test, so I'm on the microscope source at the moment, switch to the webcam, which is that one. So this is the camera built into my iMac, and you can see the field of view is much broader, but at least on the preview, the image quality looks really bad in comparison. So if I switch to this one, I think the image quality is better. That's as zoomed out as I can get it. That's just the result of the lens in the camera. Okay, so where I'm yeah, crappy 720p webcams on the Mac. Yes. And since this is actually working, what I'm probably going to do now is buy one of those Elgato Camlink little devices. You plug HDMI into it, plug it into USB, and then it turns your regular camera into a webcam. So that might be a good solution for the future. I'm doing a really dodgy thing at the moment with showing the window from the microscope on one monitor, and then I'm doing window capture on that. Well, actually I'm doing partial monitor capture and then cropping it. So it's all very dodgy, but it is hanging in. Okay, so oh yeah, Scott Miller is Tinker. Yes. Hey Scott. I have a Camlink and a cheaper eBay one. Both work well. Cool. So Sion, I need to talk to you about this later. So I've got the Elgato Game Capture HD60S, which is the one attached to my microscope. But the problem with that is that I've got to run it through the the Game Capture software. And what I want to do with the Camlink is just have it treated like a webcam. I think it'll solve a whole lot of problems. Okay, so that's a whole lot of stuffing around because I've been last minute getting things ready. So, first question is, how is everybody doing today? Graham said, now is a civilized time to stream Unexpected Maker. Yes, Sion. Why do your streams always start while I'm having breakfast or before I'm having breakfast? Is that the time that you can get in front of the camera before the kids are around? So, yeah. Part of the reason that my brain is not so engaged this morning and I'm fluffing around all over the place is that over the last couple of days, my outlook on the world has not been too healthy or happy, and it's a whole lot better today. But if I had a dashboard on me with gauges that showed energy levels and will to live and all of that sort of thing, the gauges would have all been pretty low for the last couple of days. But they are much better this morning, so that's good. I'm getting back there. So I hope you're all doing okay and not going too crazy. Oh, Sion, no, there's nothing specifically going on there. If you look at what's going on objectively, it's good. So it's just one of those things where sometimes your brain decides that the world is not so good for a while and then it all comes back again. So yesterday I was in one of those states where I had no motivation, no will to do anything, and just walking around the house was more effort than I could be bothered doing. But I'm all right now. Tradie says, I find drinking lots of booze helps. Oh, Burn says it's 2 a.m. Well, thank you for hanging in there. All right, so let's have a look at some of these questions. Oh, I'll get back to questions. I just wanted to show you something cool. Got to switch to a desktop. What have we got here? So we're back to the built-in front camera and a browser. Now something that I've been sort of watching for a little while, it's a little bit off topic, but I think this is cool. There's an Australian artist named Dana Sabera who has a big collection of classic Macs, and this shows part of Dana's collection, and looks like there's a clone in there. It's like one of those PowerPC clones. It's a whole lot of old Macs. You can see some, there's a Power Mac G4 there. There's one of the Mirador G4s. I've actually got one of those out in the garage. Some other things, lots of phones. Oh, there's one of the big speaker systems that I think used to go with the Cube. And you can see a few of the older Power Macs and 6800 series Macs in there. And so Dana likes messing around with Photoshop. So over the last little while, if you've been following Dana's stream, you would find all sorts of things like this. And it started off fairly subtly. There were some posts of Macs that you would look at them and think, oh, that's really cool. Someone has decorated an SE30. And then after a while, it started to become apparent that these were not just decorated Macs. For example, there was this one that came out, Quadra 920 Mini Tower. And people started going, hang on, Apple never made a Quadra 920 Mini Tower. What the hell is going on here? And there were, I haven't started from the beginning here. It goes way back beyond this. There are some rather unusual ones back here as well. Oh, check this one out. Tall iMac. So that's a double height iMac, 2-screen. And coming along through the timeline a little bit, find something interesting. Oh, this one. Here we go. So this is the Power Macintosh Laser Writer Select. An all-in-one Macintosh and printer. And here we go. Macintosh Quadra 200 68040 with a 9-inch Trinitron and a slot-loading CD-ROM. And these concepts are just amazing. There are some, 27-inch iMac with a CRT. And some of them are, I think some of them are being approached ironically, like this is such a ridiculous idea that you would never do it. And some of them are sort of in that area where I look at it and think, I really want that. That would actually be just a straight up cool computer. Some are ridiculous like this one. So a tiny little screen and a very weird keyboard. But the keyboard is cool too. Just because it's so small. Missing a few keys there, I think. Yeah, here's one. Macintosh Color Classic 3W, full page. So a wide view. But then some of them, like you look at this, Apple Network Server 80. And aesthetically, that is actually really cool. Now I know it's a bizarre combination of peripherals and things, But still, that looks like an Apple product. You could imagine that in the Apple store like 10 years ago. Oh, and software. So Macintosh System 7, System Acellin Septimus 500 milligrams. So Macintosh System 7 tablets. G3 mini tower. The proportions on this one aren't too good, but it's kind of cool. And the L is for Laserdisc. A Power Macintosh, what's it, a G3L, and Macintosh Quadra 950 Pro. Anyway, I could spend ages going through these. They're very cool. So if you're on Twitter, go and check out user NanoRaptor. But there is a point to all of this. Oh, here's a cool one. PowerBook G4 Landscape. So just put the hinge on the side, open the laptop up. That is truly bizarre. Oh, look at the comment on this. Tyler said, every single one of these is awful and I love them. Please never stop. Yeah. Apple NAS 800 series. So removable discs. Oh, Dana's here. Hey! I didn't realize that you're on the stream. This is what social isolation does. Yes. Oh, and this one. I was really impressed by the effort that went into this one. So this is the sticker. I think this is the sticker that was on like one of the originals. And so, oh, well, that's good timing, Dana. So macOS 9 in 5K. Got a bit of screen space there, bit of extra real estate. Oh, and look how small the menu bar is up there in the corner. Windows 95 in 5K. Oh yes. Where was it? Apple Extended Keyboard 3. There was another keyboard. Oh, this. The unloved first Macintosh Mini. There's something about this that just makes me want it so much. I think it's the proportions are just absolutely spot on. It looks beautiful. So designed all around the CD-ROM. I really liked that that old aesthetic. And then there was the backwards keyboard. Oh, here it is. So this one really got my attention as well. The keyboard with the numeric keypad on the left side. And I've always said that this is how keyboards should be, because normally you have your mouse on the right hand side and then your left hand might be on the keyboard. So often if you're using WASD or something for navigation on the left, and you want your right hand on the mouse if you're playing a game, then everything gets pushed across too far. Or if you're doing data entry and you want your left hand on the numeric keypad. So I saw this and I thought, yeah, that's actually how keyboards should be, because then there's space on the right for the mouse and the keypads are right in the middle and the main keyboard. Some more fun things here. So what we're getting to, if I come up far enough, oh, this one is so cute. Macintosh Quadra 400, sold millions, but most are lost, having fallen down the back of desks, couches, and the pockets of jackets. You know what? Because Dana has been going crazy designing all of these things, I keep thinking I want to actually make one. A combination of 3D printing and maybe some cutting, although I wouldn't want to cut too many classic old Macs. I've got a few classic old Macs myself, but I wouldn't necessarily want to destroy them. Oh, PowerBook 100 with a Retina display. Okay, we're getting up close to current time. Oh, the PowerPod. Oh, I'm not even going to get into those. I look at those and they break my mind. And then this one. This one was put up, when was it, yesterday, day before? So 12-inch titanium PowerBook G4. Oh, that would have been my dream machine. I love the, particularly if that was with a Retina display, that would have been very, very nice. But what really got my attention with this is the distinctive blue and yellow back in the corner there. And if we zoom right in, it's looking pretty dusty, Dana. It's obviously been sitting around for a while. Probably an appropriate age, though, for when that hypothetical Mac might have existed. And there's a, sitting on top of the experimenter's kit, you can see the LCD and keypad shield, which on a live stream a long time ago I brought up in Eagle and showed the design for that and the mechanicals of how the display fits in from the back of the PCB. So that was a bit of a trip, looking at Dana's pictures and seeing the experimenter's kit pop up in the background. Alrighty, so what are we doing today? What are we doing today, brain? Taking over the world, same as always. Alright, so just jumping back into the chat to see what we're going to talk about today. Southpaw 78 said, sounds like depression, monitor that closely and seek help if needed. Yeah, that is a very good observation, and I should, just as a general thing, one of the reasons that I started this live stream again, after not doing them for so long, was to try to get more of a social connection going on. And one thing that I've noticed, I'm personally a fairly reclusive sort of person. So I work from home. I go out to Chris's place a couple of days a week and work with him, which is fantastic because that gives me some social interaction. But I tend to prefer being fairly solitary. And what I've noticed is that even for myself, who kind of likes this situation and the whole idea of being cut off from society is kind of a positive thing hypothetically, in practice it's not so positive. And so it's really important that we all make sure that we're looking after ourselves and look after the people around you. And so why I wanted to get these live streams happening, and also the reason that I was screwing around this morning with the camera setup, is I'm experimenting with different things I can do with OBS to bring different video sources in. I want to be able to bring in things like a roving camera so I can walk around the lab and show you things. But I also want to be able to bring in video sources from other people and then bring in guests onto the show. Make this much more interactive, because right now it's me in front of a camera and I've got a text chat there, and the only way I can interact with you is through text. And I really want to be able to have other people come on so that we can have two of us on at the same time talking about some subject. And I want to be able to do things like have a call-in show and bring people on, ask a question, chat about something for 5 minutes, and then have someone else come on. And so I've been talking to Unexpected Maker and a couple of other people about coming on. And so hopefully once I get OBS all set up, I'll be able to do that. But it's all been kind of flaky at the moment. Hey, Scott said, you have a 3D printer and electronic skills. Yes, I have been seriously looking at some of Dana's designs and thinking, I would like to have that sitting on my desk for real. Maybe with a Raspberry Pi or something inside it so that it's functional. But back to the point is, make sure you're looking after the people around you and supporting them, and look after yourself and pay attention to how you are feeling, and make sure that you seek help if you need it. So for me personally, I don't think I'm in a particular risk situation. It's just sometimes your mood starts to be a bit lower than it should be, and motivation is down. So it all goes in cycles. My Mac Pro is from 2013, vintage, Johnny Bergdahl said. Yeah, my iMac that I'm using right now is 2013 as well. And my main laptop that I use every day is a 2012 MacBook Retina. Alrighty. And Larry said, I still have my TRS-80 Model 1. Doesn't work, but I have it. Yeah, and on the live stream last week, I showed my Tech 1D, my Z80 based computer, which is currently sitting over in the corner, and I still have dreams of linking that into my home automation system somehow. I don't care how, I just want it to be doing something so that I can say I'm running a computer from the early 80s as part of my home automation system. Yeah, and Guru said, I'm quite reclusive in person, but I get my social interaction through connections to people on the net and prefer it that way. Yeah, that's largely me as well. Many of you have probably heard that thing about the difference between extroverts and introverts, where an extrovert gets their energy from interacting with people. Introverts, it costs them energy to interact with people, and I'm definitely on the introvert scale. So interacting with people, I love doing it, but it takes energy out of me, and then I have to recharge. So things like conferences, I absolutely love conferences because it's this really concentrated period where you can get to see a whole bunch of people doing interesting things and interact with them. But I come home from conferences exhausted. So I go through, most of the time I'm fairly isolated, not really interacting with people in person very much, just online. And then I have these intensive periods where I'll go along to a conference and spend almost a week barely sleeping and just talking to hundreds of people, which is fantastic. And I love doing that, but it takes it out of me. Okay, so Frank said Tech 1B. Yeah, that's a very obscure computer that was made here in Melbourne back in the 1980s. It was designed by a couple of local guys and sold as a kit through a magazine that was produced called Talking Electronics. So Tech is Talking Electronics computer, and it was a Z80 based system. So it ran at, I think the original version had I can't remember what sort of oscillator it had, but the upgraded version ran at 4 megahertz, and it had a couple of, if I remember correctly, 6116 static RAM chips. So, and a hexadecimal keypad and some displays to show the address and the register values. And that was pretty much it. So that was my first computer. Anyway, I showed that on the live stream last week. Alrighty. And last week, right at the end of the stream, we had a question that was way too big to get into in the last 2 minutes, which was about testing. So if anyone is really keen to talk about that, then maybe I could talk about testing. But I'll leave that on the table for just a minute. So Dana said, I have a VT100 I bring out from time to time to connect to my main iMac and IRC for a bit. Yeah, it's really sad, the amount of old equipment that many people have had and then just disposed of over the years. And when I was at uni, so back, I was going to, when I started it was called Chisholm Institute of Technology, and I started a degree that I never actually finished. It was a Bachelor of Applied Science in Robotics and Digital Technology, and while I was there, Chisholm was taken over by Monash, so it became part of Monash University, and they cleared out one of the computer labs. Well, not really a computer lab, I think it was one of the behind the scenes things, and they ditched an old mainframe, including a whole bunch of VT100 terminals and some racks and various other things. And I ended up grabbing a bunch of it. I borrowed a station wagon and took my car down there and loaded it up. Took a couple of trips worth of terminals and card cages and different things. And in fact, I still have some of them. back, I don't even know what sort of mainframe it was from. I think it was from a DEC, like a Digital Equipment Corporation mainframe. And they are still in storage at my mum's place, actually. But I don't think I have any of the VT100 terminals left. Oh, Frank said, I had one as well. So this is in reference to the tech computer. Colin Mitchell from Moorabbin. That's right. So Colin Mitchell was the publisher of the magazine, which was called Talking Electronics. And this is actually leading into something that I would really like to talk about. So what I didn't plan to talk about this, so I'm kind of going to make it up as I go along. What I found really interesting about magazines like Talking Electronics was that they tended to show fairly basic electronic building blocks. Now, when you, at least the way I think of electronics, I tend to think of it in a very modular way, and I tend to think of software in a kind of modular way as well, because it helps me to get my head around it. It means that I don't have to understand the workings of every little part of the system. So if you've got a schematic and you just look at it at a whole, it can be really confusing. And it's a big collection of parts, and they're all linked together in different ways. And if you try to understand the whole thing in your head at the same time, it can be pretty much impossible. And the same is true when you're looking at software source code. If you just look at the entirety of the source code, you won't really understand it. So what you have to do is conceptually break it down into a series of building blocks. In a typical electronic circuit, you'll have a section that is the power supply, so there'll be a voltage regulator or whatever. And then there will be other building blocks that do different things. Now, once you have a building block that is functional, you can largely ignore how it's working internally, provided that it's behaving the way you want it to. So I have go-to power supply designs, for example, that I use on different things, depending on what voltage I want, how efficient I want it to be, whether I want to use switch mode or linear or whatever. And so the way I tend to think of electronics is very modular. And something that I've noticed over probably over the last 15 years in particular is that the way people get into electronics, coming from something like the Arduino point of view, is not really so modular, not as modular as it used to be, and it's also not as low level. And where I'm going with all of this is that what I would really like to do is produce some educational material or some content that would help people to learn how things work at a more fundamental level. And this really ties back to things like the old Talking Electronics magazine and other things like Dick Smith's Fun Way into Electronics, which if you were in Australia studying and you were vaguely techie in the 80s and 90s, you would absolutely know Dick Smith's Fun Way into Electronics. It was in schools. There were so many copies of it printed. And it came out in 3 editions. So the first one started off with very small building blocks. And at the time, I didn't really understand the process that was being used to teach it. But in retrospect, I understand more about what was going on. And in fact, I'm going to go and grab something. So what I'm going to do is switch back to front camera, and somewhere just over here, I'm going to be off camera for a moment. I'm going to get something, if I can find it. I think it's here. Maybe it's not. It might be in the garage. Oh yeah, I found it. Okay. So what I've got here are some copies of Dick Smith's Fun Way into Electronics. Let's chuck this back on and I'll show you what I mean about this. And then we'll get into what I have in mind for it. Now this one, yeah, I think this one was mine originally. No, I've had a couple of these over the years. So I had one of these when oh no, this one wasn't mine. I bought this one secondhand to replace one of the originals. So this was first published 1979, and I first got a copy of this. Oh, there it is. In fact, let's switch back to the better camera because I want to be able to show you. Oh, there we go. So this was originally written in 1979, and the idea is that it made it very simple to put together basic electronic circuits, and it was done by using mechanical overlays. Now if you look in the back, here we go. This is a very awkward way to be showing this. So in the back of the magazine or the book, there were these overlays, and what the idea is that you would cut this out with a pair of scissors, and then you would stick it to a piece of wood, like chipboard or something, and drill holes in it where the dots are, like a dot there, for example, where a joint is, and then put a wood screw in at that point, straight through the paper. And what you would have is a representation of the physical layout of the circuit attached to the little piece of wood. And then you would physically get the parts and put them onto the wood and do the screws up to hold the legs. So if you wanted a resistor, for example, between 2 points, you would use a through-hole resistor, and you would put the legs so that they go between the two screws, and you would screw it down. So the thing that I find really interesting about this is that it is both a schematic and a physical representation of the layout. And I think this is partly something that's missing in a lot of electronics education, is the correlation between those two things. So David Thornley said they had a plastic base with a grid of holes, and yes, that's right. So the very first ones that came out, they didn't have those plastics. And in fact, we'll get back to those plastics later. What they had was, after this had been out for a little while, what they did was come up with an injection molded plastic base which had the holes in it already on the matching grid. So what you'll do is put your piece of paper on it and put the screws through into the plastic base, and then put the parts across it. And then when you wanted to build something different, you'd undo the screws, take the paper off, put the other piece of paper on, and then put the next thing on. So, but they didn't actually have that. When the first editions came out in 1979, the instructions, I'm not sure if this one is that old or not, this one was printed in 1982. What they did, oh in fact, yes, you can see it. So this photo in here, oops, got to get the position right, that is, it's very hard when everything is reversed and I can't get focus. There we go. So that is a piece of chipboard with the paper on it, and then screws down through the paper, and then the components have been fastened to the screws, well, clamped down by the screws. And so what you can do is look at that and you can see the schematic, but you can also see the direct one-to-one correlation of the parts to the schematic. And the physical layout matches the schematic, which is interesting. But that's actually only one of the interesting aspects of this approach. The other interesting aspect is that it takes functional building blocks and then builds them up. So, for example, so that was volume 1. which I don't think it didn't even say volume 1 at that point because I hadn't written volume 2 yet. And so it goes through a series of projects which build up in complexity. And oh, somewhere there was a diagram I saw. Oh, so it's got a section where it shows you different parts and techniques and how to link things together. So that's continuity testing. And oh, here it's got a thing that shows the screw holding the legs of the parts down to the board. And it meant that with nothing but a screwdriver, a bag of parts, a base, and a piece of paper, you could put together electronic circuits and have them successfully work, which was really cool. And then volume 2 came out, and this gets more into the modular thing that I'm talking about. So this is Dick Smith's Fun Way into Electronics volume 2, which directly followed on from volume 1, but it used PCBs and soldering. The idea was that you could do all of the projects in the first one with no soldering, and then in the second one it took the same sorts of concepts, and it's got things like parts and like a picture of a part and an explanation of what it is. And in fact, if you've got one of my experimenters kits, like the one shown in Dana's picture, when I wrote the guide for that, I specifically had this in mind. I was following this concept of representing parts in a way that people could understand and explaining what they look like and what you do with them. So there's a whole lot of really useful reference stuff in the front, like reading circuit diagrams. There's Ohm's law and how component marking codes work, so that if you've got a part you can look at it, look at this guide. So for many people this book became a reference guide. For many years I had this always within arm's reach, and if I wanted to look up a value for a part, I could look on here and use this reference material to see what it was. Assembly hints and tips, how to solder, and if we get to the first project. Okay, so this is a representation of the concept that I'm talking about. And this project is built on a PCB, like all of the projects in this particular book. There's all PCB, and it's got 2 transistors and an LED and a couple of other parts on it, 4 resistors, 2 capacitors. And you can see here on this page, there is the overlay, which shows you where the parts go, and below that there is the schematic. And the layout of the PCB is very close to the schematic. You can see that it's got the 4 resistors mounted vertically, it's got the capacitors in the middle, it's got the transistors down below on the left and right. So once again, it's a fairly close correlation between the schematic and the physical layout. Now, you might be saying, well, that's nothing revolutionary. Of course, the physical layout follows a schematic to some extent at least. But for me personally, when I was learning all about this when I was like 10 years old or whatever, I can't remember how old I was when this one came out. Yeah, 10. It makes it much easier to understand conceptually. But the point I was trying to get to is this is a module. What we're looking at here is something that is presented in the context of building an outcome. In this case, it's a flashing LED, and it's a flashing LED in hardware. So this is project 1 in the book. It's Blink, but in hardware. No microcontroller, no software involved. And this is the original Blink, way before Arduino or anything like that existed. And so you can see that this whole tradition of the first project that someone working on being Blink and making an LED flash goes back a long way before Arduino. So this is 1980, this is 1979. And the key here is that what you do is give an outcome like a flashing LED, and the idea is to build a flashing LED, but what you're doing along the way is teaching astable multivibrators in a stealthy way. It's like guerrilla education. What you do is you give someone an outcome and show them how to build it, and in the process of building it, they learn a little building block that can then be useful later. So if you build this project and you take the time to look at how it works, and you look at the schematic and there's an explanation, oh, there's a section right there, how it works, and you look at the explanation of how this works, you get to the end of this project, and then you have a little building block that you can use. In this case, it's an astable multivibrator, which is an oscillator, and it's essentially generating a square wave. What you're doing here is making a square wave oscillator and driving an LED off one part of it so that you're visualizing the square wave. Now, a 10 or a 12 or a 20 or 50-year-old person who is building this project doesn't necessarily understand that at the time, but it is creating in their mind the basic knowledge of some little building block. Now, the thing is that if you said to me, close this book, grab a notepad and draw an astable multivibrator, I probably couldn't do it. I might come up close to it, but I know about that as a building block and I understand the concept of how it works. So I could look up a circuit for an oscillator and then I could adapt it to whatever it is that I need. So what I think is really powerful about these, and there is a third book as well, which I don't have here, is they present very small bite-sized chunks in the context of some outcome, like a project that you want to build, and along the way you're learning about fundamentals of electronics, like oscillators, and in this one there are amplifiers, and like in this particular case they're like the Ding Dong doorbell, which is project number 2, uses a 555 timer, so you learn about 555s, which seems kind of old-fashioned, but it's very useful knowledge. Morse code trainer. So this one is, what is this one doing? It's just an oscillator once again. So it's making a tone in an extremely simple way. It's just a single transistor oscillator. So, okay, so quite some years ago, I got to thinking how much of a shame it is that this sort of resource doesn't really exist anymore. And if you've seen anything that's like this, that's modern, I would really love to see it. And so what I did was take a lot of those designs. So like this is one of the kits from Funway Volume 2, unopened original. It's got the PCB and the parts in it. So the idea is that you would buy a kit and all the instructions are in the book, or you could just source the parts yourself. And what I did was I ended up re-implementing PCBs. So this is a PCB, for example, for that first project, the flashing LED, from volume 2, I think it was this one. It must be. Yeah, so multi-purpose flashing LED. You can see the PCB there. I re-implemented it all in Eagle, so that's my implementation of the PCB. And it follows the same dimensions, so it fits in the same box as the original. It's got the physical outline, and I even went to the trouble of using organic tracks, because the PCBs that came in all of these kits were designed by hand with a pen on some film and then reproduced photographically. So if you look at that PCB, you'll see that the tracks down around this end, for example, sort of curve, down around there. It's got this very organic sort of feel to it, which I quite like, and it's kind of inviting. And you can see large chunks of copper around here which have been filled in, and it's because the person that designed this literally had a marker pen on a piece of transparency or something and was drawing the track in, and then when they want to fill in a large part of the track, they just, you know, draw it in and fill it in, make a solid chunk. And wherever on the film the ink goes around, that is then photographically transferred to the PCB, and then when it's etched, that's how it comes out. So what I did when I was implementing this was do the same sort of things. Oh, the reason I can't get focus close up on the camera there is that the autofocus on that camera is terrible and I turned it off. So it's currently fixed focus, which means that when I move something close to it, you can't see it. So I'm going to find something to show you. Let's switch back around to, we'll come back to the desktop. And I can't even remember what prefix I used for these projects. Maybe under F for Funway. So I re-implemented a few of these. Come on, oh there it is. Flashing LED, this one. I'll drag this back over. So this is my re-implementation of the Funway Volume 2 Project 1 flashing LED. And you can see that it's actually a single-sided PCB because it doesn't need to be anything else. And the tracks are all curved in a sort of organic way, trying to make it look like it was all done by someone with a pen, even though it wasn't. And I've ended up designing a few different projects out of this. So there's some of these are incomplete, I was just messing around with them. But this is the Ding Dong Doorbell project, project 2. And this has got the 555 in there. It's all through-hole parts. And the idea was to try to bring back some of the resources that were available previously to go along with these books. So things like this, if you really hunt around, you can find original unopened projects that go with these books. But these are collector's items now, and they're very rare. And so my concept was to bring out a compatible range of projects. Oh, there's the Ding Dong Doorbell PCB. Here's a VU meter, which is one of the other projects out of the out of Funway Volume 2. Where's the VU meter here? Oh, and I've got others. So this one hasn't been fabricated, but there's the Morse code trainer. And oh, I've got universal timer and alarm. Oh, I did more than I thought. I thought I'd only done a couple of them, but it turns out that I ended up designing PCBs for quite a few of the projects in Funway Volume 2. And this is the VU meter. So the idea is that you provide an input onto this from some audio source, and then the number of LEDs that illuminate is based on the loudness of the source. And this is showing this is explaining a concept as well in terms of the way the circuit works and the way each of these LEDs gets tripped at a different threshold, and building a ladder essentially of these. Now if we come along to the schematic, you can see it there. Anyway, Unexpected just asked, when did I design these? Good question. 2016, according to the date on this one. So this was October 2016. And so what I had in mind originally for this was just to make available kits that would be compatible with the books, because I really wanted people to be able to use this sort of educational resource again. And I think it's a shame that you can't just go and buy a kit that does something vaguely interesting and that has all of the accompanying documentation that explains it. I mean, there are plenty of kits you can buy from, you can buy on AliExpress or eBay. You can go and look up little build your own whatever kits, which are mostly a soldering exercise. They're not really something that's educational, because they just present it to you as a board with parts and say, put this together. And at the end of it, you might have learned a bit about soldering, but you haven't really learned anything about how the circuit is working. And so then the next logical step on from that was, well, how about bringing back the books? And I got in touch with Dick Smith about it through my friend Carl von Moller, who was up in Sydney. He went out to Dick's place for an event. It was for a Dick Smith Electronics reunion, and so Carl took my boards with him and showed them to Dick, who thought they were really cool and wanted to bring them back. So this was back in 2016, and then I hit a bit of a snag, which is that Dick himself sold the company many years ago, and the company then went bankrupt, and then many of the assets were bought by Kogan. So if you go to Dick Smith Electronics, if you look up Dick Smith Electronics now, what you're seeing essentially is Kogan, which is another Melbourne company which owns all of their branding assets. But the ownership of the rights to these books were bought by a guy in, I think in New South Wales, who had a similar idea, and he wanted to bring back the books, but then nothing happened with them. So what ended up happening is nothing. Let me see what I can find. So if you go to Dick Smith Electronics now, all the branding is still there. It still looks the same. And if you come along to this, it's got, the classic Dick Smith look, but this is actually Kogan now. So Kogan owns dicksmith.com.au. But there is also a site called funwayelectronics.com, I think. Yeah, that's the one. So this site was created by Alex Cochran, and Alex bought the rights to these original books and the designs, and also managed to find the tooling. So this is coming back to that comment from ages ago about the plastic bases that he used. So with some digging around, Alex managed to find the original tooling, which I think was sitting in, might have been in Hong Kong, I can't remember, for the injection molding for making the plastic bases. And so his plan was to totally revive Funway, and I think that is a pretty awesome plan, but the problem is it all ended up stalling. So if you look at the project milestones page here, where he talks about all the steps he was taking, so January 2016 was when he started on this. Oh no, that's when Dick Smith Electronics went into administration, and then April 2016, yeah, it was around that time that the rights to all of this was bought, most of it by Kogan, but some by Alex. And so it got to November 2016 with this website going live, and then it stopped. So nothing has happened since that time. And I've been in touch with Alex a couple of times because I really wanted to help with this project. If Alex had the rights to the IP, so he had the right to reprint these, then it would make sense to take things like my designs, and I mean, I've released these under open source licenses. These PCBs are all on GitHub, and they're all released under the TAPA Open Hardware license, so anyone can use them. What I was wanting to do was contribute my PCB designs that he could use and then bring back the books. But the problem is that his funding fell through. So this project for him, this is not his full-time thing. This was just something he was trying to do on the side, and it was being backed by an American company, and then they changed their minds. Basically, they decided not to do anything with it. And right now, this is in limbo. So after all of this, I got back in touch with Dick and said that I still wanted to go ahead with this, but the problem was that we had the IP issues, and I couldn't just do this when I don't have the rights to it. So yeah, he still wants me to go ahead with it. Last time I was in contact with him, he was saying, go ahead, you should do it anyway. But it puts me in a really difficult position. I really don't want to be breaching someone else's IP. That's not the right thing to do at all. I'm fine with doing things like designing a compatible PCB, because what I'm doing here is not directly ripping off or copying the original PCB design. I'm re-implementing the project, but it's my own PCB. I've done all the design work on this. What I can't do is take the content of the book and reprint it, because I definitely do not have rights to that. But what's been going around in my head for a couple of years now is some way to get out of this impasse of not being able to move forward. So I've got these designs sitting here, and they've been sitting there for years ready to go. I mean, I've actually got physical PCBs, they're all ready to go, but I can't do anything with them. So I was thinking of just rewriting it all myself and doing something that is a derivative or equivalent to it, but is not the original Funway. And one thing I definitely can't use is the Funway into Electronics brand name, because that's owned by Alex. I'm not sure if it's Alex personally who owns it, or if it's his financial backers that own it. In any case, I couldn't just bring out Dick Smith's Funway into Electronics, updated for the 21st century. Wouldn't be legally right, wouldn't be morally right. Even though Dick himself wants me to do it, I shouldn't do it. And so I've been thinking of things like bringing out a range which was like freeway into electronics, based on Freetronics, obviously, and really take this concept. I wanted to take what Dick Smith did with this Funway range as an educational resource, so showing the correlation between the schematic and the physical layout, and showing the modularity, building things up from very simple building blocks and then progressing through to more complex projects, and bring it back. I think that would be a really cool thing to do. Alright, I'm going to take a break from random talk for a minute and try to catch up on some of the chat, see if there are any questions about any of this. Alright, so YTFP Chris said, still viable today, who needs a PCB, just some screws and some wood. Yes, exactly. And that was one of the things that was really nice about the original Funway. And the thing is that people are very adaptable. They can learn lots of new things at the same time, but it's generally most efficient if you learn one new thing at the same time, or one new thing at a time. So trying to learn how to solder, for example, is a specific skill, and trying to learn how different components work is a different sort of skill. So if you can take away the issue of soldering, both as a safety issue for younger kids, and just as a difficulty of something that is an extra barrier, it's more tools, then you can lower the barrier to entry. You can make it easier conceptually for someone to say, I want to make an electronic circuit. I've got a little bag of parts that only costs a few dollars, and I've got a piece of wood and a screwdriver and some screws, and then I can make a circuit that works. And then going on beyond that, once they're comfortable with that and they've made some things, they want to make it more permanent, make it neater, learn some more skills. That's when you introduce in volume 2 PCBs, and then putting parts onto PCBs, soldering them into place. But by the time people have got to volume 2, they've typically gone through volume 1, which is assembling things using a more mechanical approach. Yeah, alright. I had the spring kit. Cool. Oh, spring kit. Yeah, so Bernd Eckenfeld said I had the spring kit. I'm not sure if that was the Dick Smith one. There are also some other systems. So in the US, there were the Tandy kits. There were like the Tandy 100-in-1 and 50-in-1 kits. Those were probably the equivalent, and they were around in Australia as well. But with those, generally what they had was a large base, and then there were springs sticking up out of it, and you could put wires into the springs. And because the springs were compressed, they would make electrical contact, and you could just pull things out and plug them in. Now the X-in-1 kits generally had, from memory, they generally had modules, which was good. They had a large base and then different modules, so there might be a meter and there might be a resistor and a light sensor and a power source and those sorts of things. And then you use jumper wires to link them up. Now that is okay, but I still think conceptually it's not as good as going down to the individual part level and linking them on a board. And also, the other limitation of the X-in-1 kits is that you can't physically rearrange things so easily. I think they used to have sections where there were like just free-form springs and you could put parts in them. But generally what you would do is say, I want to take this particular thing over here and I want to link I'll use some jumper wires to link that to some other part. But the original things stay where they are. And so you end up with a bit of a painting by numbers effect where you look at the instructions and it says join this to this and put this link across here, but conceptually in your head the layout of the parts does not match the logical flow of the circuit. So the schematic doesn't have a one-to-one correlation to how the parts are set up, and I think that is probably one of the big limitations of those early electronics learning sets. So those are okay. I never really got into them, but my preference is for this approach. All right. Oh, and Bern said there was also plastic boxes with magnets. I think Fran recently reviewed them. And Gary said, built crystal set radios as a kid on cigar box lids using brass screws and brass screw cups. Exactly. So I don't think Dick Smith was original in coming up with the idea. That sort of thing had been done for a while. And there were magazines, I think mainly in the US, that would do things like show how to use a piece of wood, put some screws into it, and then use that to join, basically like using as tags and point-to-point joining components. So that approach was already around. This isn't a totally brand new thing, but what this did was put it into a series of projects that started simple and then progressively built up over time, not just as a one-off thing. And I think that is really useful. Once you get, it's like it's that whole gamification thing where you give people some positive feedback. You get them into a positive feedback loop. So have a very simple first step. Project 1 is quite simple. It's a small number of parts. You put it in and you get a blinking LED and you get that little kick and you go, hey, I made something that works and I can see it, and then I can show it to all my friends and they can see how cool I am. And then the next step is something that's a little bit more complicated or a little bit different and builds up. So it's not just a one-off project. Building a crystal set is awesome. In fact, there's a crystal set is one of the projects in this. But I think what is more useful is having that in the context of a whole sequence of things that you can do. So you start off with a very simple project, put it together quite easily with a very high probability of success, and then build people on from there and take them through a whole series of things. I can't remember how many projects. I think it was 20 per book. Yeah, so Funway Volume 1 had 20 projects in it, and Volume 2 had 20 projects. I can't remember Volume 3. I don't physically have that in front of me right now. I think that might have been 20 as well, which are a good bite-sized chunk. You can take on a project that might take you a couple of hours to put together, and then you get the reward out of it, and then next weekend you do the next one. It keeps you going on and building your confidence and your knowledge. All right, so oh yeah, Unexpected said, I think it's a fantastic idea to have something, to have a compatible range of stuff for the books, but are the books easy to find, and are they encumbered now that DSE is gone? Yeah, that is exactly the problem. So the issue is the IP in the books. Okay. More comments. I am so far behind. Dodgy Brothers said, so was it a branding thing like Hungry Jack's and Burger King? I think that was in relation to, is that in relation to Radio Shack? I'm not sure. I've missed so much of this. Yeah, Tandy and Radio Shack were the same. Then Radio Shack dropped the Tandy name. Then they went broke a few years back. Yeah. Oh, NMN's I can't say this correctly. NNM says, hi from Chicago. Hey. It's so cool that there are people everywhere watching this, participating. And Daryl said, I gave my copies of the books to a teacher. We have a large number of people following you. Some must have skills like writing and so could help write new content. Yep, that's true. This is the sort of thing that could be done as a bit of a collaborative effort. I've done a little bit of writing in the past as well, and I'm not actually scared of the writing part of it. That part I can do fairly easily. And in fact, just as a bit of an experiment a little while ago, I started writing a new equivalent to Funway Volume 1. Or was it Volume 2? I think it might have been Volume 2. I started writing some of the sections of what would be an equivalent book just to see how it came together. Oh, Scott just asked a question. Would you agree that anyone who doesn't have a minimum grasp of theory should somehow be blocked from publishing how-tos online? Are you talking about me? I hope I wouldn't be blocked from publishing how-tos. That is a can of worms question. I think anyone should be able to share whatever they find useful. And there have been times where I've come across things where someone has been explaining something and they're very confident in their explanation, and I just know 100% that they're wrong about how they think it works. So I've seen things that make me think, no, this shouldn't be allowed, but I really think we should be open to people participating. No, it's not beer, it's a glass of water. When I'm doing these live streams, my voice always seems to go, so this week I came prepared with a glass. But Scott, I would be really curious to know what prompted that question. What sort of circumstance in particular? All right, so there is a... Okay, this is a question that might get us way off track, but I'll just mention it now because I'll probably forget later. Kay, who has a mullet, said, any advice on next stage steps for taking an Arduino-based design to a commercial product? Is it best just to engage a company to do this based on my original design? Hoo boy, that's opening a can of worms. Maybe we'll put that aside for now and come back to it if I remember. I'm so tempted to say some things about that right now, but I'll try to resist the urge. Oh, Dodgy has a response to that as well. Oh, and Dale said, with how easy it is to design a PCB and get it made these days, it seems wasteful or even harmful to be giving people finished boards. Better to give them a kit of parts and teach them how instead. To some extent, yes. But a lot of the time, well, one of the difficulties, okay, so a few years ago, quite some years ago, probably far more years than I would want to recall, I did a project which was, let's see, which was called the, let's see, I'll just find it. Oh, it's called the Kitten. And that was because I had a, here we go, switch views. So, talking about the difference between providing someone with a finished board and providing someone with a kit. Now, way back in the early days of Arduino, before they got to the naming scheme where they had Uno for the first Arduino and Due for the second Arduino, they were named for numerically in Italian for different purposes. For example, there was the 10 Mele, the 2 Mele Nova, and those ones were named to celebrate when they produced, for example, 10,000 boards. And so the 2 Mele Nova was when they got to, I think it was the 2009 edition. I think that means 2009 in Italian. And so around 2009, when the 2 Mele Nova was out, I was talking to the Arduino core team about what was going to be the next board that came out, what was going to come out after it. And I had done the design for an equivalent board called the 2010, and I named it that because it was, the idea was that that was going to be the Arduino 2010 design. And so they ended up, so they had another designer working, which ended up becoming the, Dodgy said, John is like a dog on a leash when it comes to questions. Oh, look, a tree, yes. I go off on so many tangents. So the board that ended up coming out was the Uno. So I had designed the 2010 as one possible design for the new version of the Arduino, the official Arduino, and they ended up going with a different design, which was the Uno. That's how it became known. But I still had the 2010 design, so in fact I wonder if it's even online. It might be. This might just give me a 404. Oh no, there it is. Okay, so this was the Freetronics 2010. So it's got the USB to serial converter up there. That's the FTDI version, which is the same as on the early Arduinos. And this design looks so dated now. I am so many layers deep in going off on tangents right now. So I'm talking about the name of the 2010, which I designed in 2000, and I think I actually designed it late 2009, might have been early 2010, as the 2010 edition Arduino. But at the same time, I wanted to have a version that was available as a kit. So there is actually a point to all of this semi-random. Let me resize these things here so we can see them side by side. So what you can see on the right is the 2010. This is, as you can see, surface mount parts apart from the headers and the socket for the AT Mega, but it's all a pre-assembled board. And over here you can see the kitten, and I thought this was a cute name at the time. So it's a kit version of the 2010, and it's all done using through-hole parts. And you can see the correlation here. The kitten doesn't have the USB to serial converter on board. It's got a 6-pin header in the FTDI format, and apart from that, it's very similar. So we've got the through-hole AT Mega. It's got the crystal, which is through-hole in both cases, but it very much corresponds. You can, in fact, see here on, you probably have trouble seeing my cursor, but over on the, just to the right of the crystal, on the 2010 on the right, you can see 2 resistors and a capacitor, all surface mount, in between the reset button and the crystal. And if you have a look on the kitten, you can see 2 resistors and a capacitor, but they are through hole. So there is almost a one-to-one correlation between the design of the 2010 in surface mount and the kitten, which is through hole. Now, what I wanted to do at the time, or my reason for doing this, was to have a kit. Excuse me. I wanted to be able to provide a kit to schools and other places that might want to get people to learn about soldering. I'm going to hit mute and cough for a second. Please excuse this temporary interruption. Okay, hopefully that is better. The point I'm getting to here is the economics of it. It is cheaper to produce the fully assembled surface mount board on the right than to produce the through-hole kit on the left. Scott, yeah, I don't even really like beer, but I could do with a soft drink or something. The only time I can drink beer is if it's really hot and I'm really thirsty and I've been doing something like doing physical hard work or something, and then I can handle drinking some beer, but not much. I don't know why, I just don't like it. So here we have the tale of 2 Arduino compatible boards, and it costs significantly more to produce the unassembled kit on the left than it does to produce the fully assembled board on the right. And there are a whole bunch of reasons for it. So the 2010 went out of production quite some years ago because it was superseded by the 11, which came out in 2011. Funny about that. And is still being sold, although the design has been revised many times since then. It's essentially equivalent to an Arduino Uno. And the kitten I ended up retiring because it was so labor intensive to do these kits. Now there are places that have done a really good job of automating, or at least semi-automating, the process of kitting up. Seed has a really interesting production line that they use. In fact, last time I was in China, I went to Seed Studio and to their offices and to their factory, and they've done a really clever thing with the way their production line is set up for putting parts together. What they've done is repurposed lolly packaging machines for packaging electronics parts. And the way the lolly packaging machine works, this is going to be a whole lot of hand waving, but basically the lolly packaging machine has the packaging that comes, it's normally closed, but except that it's open on a roll, and then it goes into a little slot with a V shape that folds it a bit, and then parts are dispensed into it, and then it gets folded more and then heat sealed and cut, and then the whole thing moves forward, and then more parts get dropped in, and then it gets heat sealed and cut. So they've got this machine that has parts being fed into it from the side, where normally they would be, lollies being dropped in, and then the machine is heat sealing them into plastic bags, essentially. And the machine just keeps running, and it keeps making more bags of parts. So that sort of thing is really clever. If you're putting together kits and you want to automate taking a whole bunch of headers and counting them out and then putting them into the bag, then you can adapt things like machines from lolly production lines to do that. But at the small scales that I work at, that's really not practical, and so it largely comes down to labor. It's someone sitting there with trays of parts and counting them out, and they're saying, I need 7 of these capacitors in the kit, and I need 2 of this resistor, and I need 1 of these sockets. And it's error prone and very laborious. And then you have to package them somehow, put them in a neat way that they're not going to get damaged. And the other issue is labeling. With things like 1% resistors, which typically have a blue body. I mean, I understand resistor values. I don't even bother trying to read 1% resistors because it's on the stupid blue background, which makes it almost impossible to distinguish the colors of the bars on it. And so if you're doing a kit where you want to say, okay, you've got these resistors, and then these are the color codes of this particular resistor value. So look for these bands, and then you found your 1K resistor. It's very hard for people to distinguish them. So it's important to do labeling properly to make that as easy as possible. I was going to say foolproof, but it's not a matter of someone being foolish. It's just a difficult problem. And so if you've got a bag of loose parts and it's not easy for someone to distinguish between the parts, you have to be able to label them. And that is labor intensive. So one way to do that is to package things separately, like have a little bag with a couple of 10K resistors in it and a label on the front, and then a bag with 1K resistors and a label on the front, or maybe to have labels that are applied to the leads. But this is all, the labor is just crazy. When you start doing some time and motion studies on this, the idea of someone sitting there and bagging up all the parts for one of these kits, it's just impossible. I did it for a while. I've had it done by contractors in China for a while, and because these have to be sold at a higher price point than a fully assembled board, there is no economic incentive for people to buy the kit unless it's specifically because they want to assemble a kit. That in itself has huge value, and I think it's really worthwhile. But the number that were being sold, it just wasn't feasible to keep making them. So, so the kitten ended up disappearing. I still actually do have kitten PCBs, and I've got parts and things, but I haven't produced those for years. Alrighty. I can't even remember what... Yeah, I am like a squirrel with shiny things. I can't remember what question originally prompted me going off on that wild tangent. Oh yes, that's right. It was a comment about it being more valuable to give someone a kit of parts than a completed board. And yes, in some circumstances, it is much more valuable, and it's actually worth paying a premium to get a kit with instructions compared to a board that's been assembled on a pick and place machine and gone through a reflow oven, and you just get it as a complete working system, because the value is in the process of putting it together. But if you don't care about the design of the board and all you want is an end result, a board that you can treat as a black box, as a module for your project, then every time you would go for the cheaper machine assembled, ready to go and tested board. Hopefully tested. Depends where you buy them. Okay. We might get back to that next stages question sometime soon. All right. Oh, there's... I am way behind questions again. Okay, so Scott was replying to Jim Amos, but he may miss the questions when someone else has sent him off on a tangent. Yes. So I've got to go back and find what Jim was asking. So is this just a free-for-all Ask JO questions? Yeah, kind of. Yeah. So okay. Yes, just as a meta commentary, I generally start these live streams with the idea that I'm going to talk about something specific, and then I just end up going, whoa, off there somewhere. A couple of weeks ago, I started with the very specific plan that I was going to run the pick and place machine. So I pasted up the board and ran the machine and showed that. That took a bit of preparation to get everything ready in advance. But usually I come into this just in a very reactionary way and and deal with whatever comes up. Yeah. Oh, yes. Dodgy made the comment, on the Discord server there are numerous topics that you can get help with projects and discuss all sorts of things. Might be better than getting a short answer in a live stream. Yeah, that is actually a really good point. I should have said that earlier. So thanks, Dodgy, for that reminder. If there are people that want ongoing help with things or want to discuss their projects, then check out the SuperHouse Discord server. It seems that I chuck this link in every single time. Just about every live stream. And every live stream we get a bunch of new people joining the Discord, which is awesome because it's an ongoing active place where you can have conversations about what you're working on. Dodgy said, I think he's wandered off the reservation today. I thought we might have had a few on-off moments. Guess it must be a big problem today. Yep. All right. Peter Kirkos said, I worked for Rod Irving Electronics when I was young and did exactly that, hand put kits together. Yeah, so you would know the pain of it. So for those of you that don't know, Rod Irving Electronics was another, I don't think they're still around, they might be, another electronics retailer in Australia, similar to Dick Smith Electronics, and followed the same sort of thing of naming the business after himself. So Rod Irving was selling kits and all sorts of different things. Candy, yeah. I've never understood why Americans call it candy. And what I really don't understand is when Americans call chocolate candy, because to me, candy is hard. It's like a sugar-based, hard-boiled lolly. Something that if you try to bite it, you'll probably break your teeth, and you suck on it for a while and it disappears. But Americans call most sweets or lollies candy, I think. What sort of word is candy? Oh, this is really interesting. David Thornley said, I shuddered to think the number of people who specialize in this at Lego Corp. Yes. If you want to see a crazy automated operation, have a look at how Lego do their kits. And in fact, I looked into this a little bit when I was, so this was many years ago when I was looking at kits and the process of kitting up. The way that Lego do their factory automation is insane. They have, for the number of items that come out of their factories, they have a remarkably small number of people, and those people are basically just robotics engineers building building these crazy automated systems. Now, one of the really interesting things that I found about the Lego process is the way they do, or one of the techniques they use for doing detection of incorrect parts in kits, and they do it by weight. So Lego parts, I mean, there are obviously certain parts that have the same weight, and so you can't distinguish them by weight alone. But if you take a kit of Lego parts, it will have a very specific weight, and because they extremely accurately control their injection molding process, the plastic that they use, the tolerances to which they make things, their parts are incredibly consistent. And if you take the same part, different pieces of the same part, and you weigh it on an extremely accurate set of scales, then they'll come out exactly the same spot on every time. So what they do is they kit up and then they weigh the parts, and if it is not exactly what is expected, it gets shuffled aside for a Q&A, and that way they can be reasonably sure that they've got the right number of things in it. So if a machine something goes wrong with a little thing that's dispensing bits into the kit, and they're missing a part, or something gets double dispensed, then they catch it by measuring the weight of the kit right before it gets finished. And you can do something similar when you're kitting up with electronics. I actually bought a set of scales to do this, and one of the ways that parts are counted out, if you go to a market in China, like an electronics market, and you want to buy 1,000 connectors, they do it on things called counting scales, and they know very accurately the weight of each connector. And in the counting scales, you program it in and you say, I am measuring out this connector, and you just chuck like a whole bunch of things on it, and the scale tells you how many of that particular item you have on it. So you can say, you can chuck on a bunch and it will say, you've got 957 connectors on there, and you just feed them on until you've got exactly the right number. So counting scales that are linked to some kind of an automation system are part of the way to solve this problem as well. James O'Gorman said, weigh in motion system. Yeah, I don't know what I'm talking about. I'm just making stuff up. So people that have actually worked in this probably know the correct terminology for all of these things. Probably is called a weigh-in motion system. Yeah, and Aaron said, same as banks count notes and coins on a scale. Yeah, it's a counting scale. Dana said, rock up to the Coles Deli, half a kilo of 80 megas, thanks. Yeah. Daryl here, this is coming back to the earlier comment about Funway 1 and 2. The teacher I gave the books to found through-hole components expensive, and it was hard work teaching 10-year-olds to solder. Yeah, so that is why I like the multi-stage approach. I'll start with Funway 1, which is just mechanical assembly using a screwdriver, and then you can get to soldering later. And that it also does very dramatically with the individual. There are 10-year-olds who can solder like champions, and there are 50-year-olds who can't solder at all. So yeah, It's just a matter of teaching people in a way that builds them up incrementally. All right, so I'm not sure how to pronounce this. Yilver paste, I think. So when I saw the schematic, I know already it was a blinking LED before you say it. Yes, that's part of the whole visual recognition thing. When you've worked with something like an oscillator and you've seen the circuit that flips between the two states, like that little astable multivibrator, because I saw that circuit and I built that project back when I was like not even a teenager yet, if I ever see something in a schematic that has that sort of structure, it's like when you're reading. Once you've learned how to read, you no longer look at the individual letters within each word. You recognize the shape of the word. It's the same with this. You see a section of a circuit and you don't need to look at the individual parts. You just go, that's an oscillator, because it has that shape, the word shape of an oscillator. So yeah. All right. And David said, wouldn't it be nice to use a layout approach, but rather than screws or springs, breadboard? Possibly. So by breadboard, I personally think breadboards are useful, and I use them a lot. I have them like right here on my bench, but I don't like them so much for educational purposes. And there are a couple of reasons for that. One is that they tend to be opaque in terms of what they're doing internally. It's when you're teaching people the very basics of, oh, Johnny, he said 3:36 a.m. here, time for sleep. Have a good stream. Thanks for coming along, Johnny. I appreciate it. So what happens is that you can show someone, plug these parts in here, and because you can't see the internal connections, that one little thing is enough to prevent people understanding what's going on. You can explain to someone on the particular breadboard, it's got the connections across the rows like this, and if you put them into the same row, then they're going to be connected. But when you are looking at a circuit on a breadboard, those connections are not visibly apparent. And also because of the physical layout of the breadboard, it means that you are forced to put parts in an orientation that suits the breadboard, not that matches the schematic. So breadboards are fantastic for quickly putting things together, but I think there is an opportunity or a need at the early stage, even before people get to breadboards, where you're showing them these particular parts need to be joined together. And okay, as a good example, if you want to show a super basic circuit where you have a battery, a resistor, and an LED, and it's a loop, you're showing the concept of current flowing through the LED, through the resistor, and back to the power source. So it's the simplest circuit, almost the simplest circuit possible. If you reproduce that on a breadboard, by the time you put the parts in, it doesn't necessarily look like a nice little loop anymore. And there are parts of the circuit that are visually broken because they are joined inside the breadboard. And that's why I think the idea of screwing parts down using this sort of approach is really useful, because you can see the entire circuit. And then when you go on to using PCBs in this, which is largely re-implementing projects from volume 1 but on a PCB, you can still visually see where the circuit goes. Now, one thing that I haven't done on this one, but I did on another PCB. I'm just wondering where it is. No, I can't even remember what project it is now. I did a a PCB design a few years ago for some really basic kit or project. Oh, I just have no idea where it is. But what I did was replicate in silkscreen on the top of the PCB the layout of the tracks, so that when you look at the PCB, when you just look at this, you can see parts on a board, but you can't see how they're joined. If you turn it over and look carefully, you can see where the tracks go. But once again, this becomes opaque. You don't really understand the direct correlation between this layout and the schematic. So what I did was just literally draw the connections in silkscreen on the top of the board, and you could look at it and see the flow between all the different parts. And I think that would actually be beneficial on these boards. Now these ones are all, I think they are, yeah, these are all essentially single-sided boards. Because the circuits are so simple, there's no need for being double-sided. This is produced as a double-sided board, but the top of it is just a it's just copper. It's not even, I don't think it's even connected to anything. It's not connected. There's no ground as such in this. It's a very simple circuit. And in the original, in fact, if I pull this one up, you can see the original PCB that was used here. Am I on the right camera? Yes, I am. You can see very easily because there's no silkscreen, there's no solder mask, it's single-sided, and it's this one was fiberglass, but some of the earlier ones were phenolic base. And you can actually see the track straight through the PCB. Because there is no ground plane or anything else on it, when you solder the parts on from the other side, so this is the track side, when you put the parts in from the blank side and look at it, you can still visually see the connections between all the parts, and it's a direct correlation between the physical layout and the schematic. And I think that is something that I lost when I implemented it like this. What I kind of overlooked is the fact that having the solder mask and the copper on the top means that the links between the parts are just not visible. So if I was going to bring these kits back now, I think what I would do is add silkscreen on the top to show all the links between the parts. I think I just took 10 minutes to answer something I could have answered in 30 seconds. Sorry. Aaron said, everyone seems to have a love-hate relationship with breadboards. The person who comes up with the design that supersedes the current breadboard design and flaws. Challenge. Yeah. Yeah. Breadboards have their place. And I don't have a problem with people using breadboards once they've got beyond the super basics. But I think what's happening at the moment is that the very first time someone puts a circuit together, a lot of the time it's on a breadboard. And so what's happening is that there is that abstraction. And we've got to get past that. I think we need to rewind a little bit and get people back to just connecting bare components together in the absolute minimum possible way, so you can see this is where the current flows. It's a circuit. Okay. All right. Oh, interesting comments here from Dana. This reminds me when I wanted to fix one of the VT100's power supplies. It has a broken 28 volt output, so it can't rewrite NVRAM settings. I asked one of the repair techs at work. I was surprised he could look at the schematic and instantly mentally rope off parts and told me what each was, and pointed to one and said, "Problem's probably here." I don't know if he was right. I still haven't fixed it. But yeah, that's a really good observation. That is exactly what I'm talking about. You don't need to read the book by looking at each individual letter and then figuring out the word. You just look at the chunk and you think, power is over there, and this is over here, and this is doing this. So then you can drill down into the individual parts. All right. Now, crazily, we're only about 15 minutes away from ending this stream. How have I just made up stuff for an hour and 45 minutes? So Dodgy just asked, anyone having problems getting a refund from AliExpress at the moment? Ooh, I haven't tried recently. I have so many orders that are still in transit. What I found so far is that I've had a couple of sellers extend the seller protection. So what happens is that with AliExpress, I mean, Dodgy, I'm sure already knows this, but just for the benefit of anybody else, when you buy from AliExpress, the AliExpress service themselves have a system where if you haven't yet received the goods and they should have arrived by a certain time, then you can appeal and AliExpress can give you a refund. The problem, of course, is with the big delays that are happening right now in international shipping, because what happens is that there is a certain period of time where the seller protection is active, and what they say is if it gets to a certain period of time that's expired, which is often like 30 days or 60 days or something, and you haven't acknowledged that you've received the order, they just assume that you've received it. And so then they say, okay, this is marked as received and you can no longer appeal it. But the problem is that orders are taking so long to arrive now that they are going beyond the protection period, and then AliExpress is saying, oh, you didn't appeal within the period. So yeah, that can be tricky right now. I've had a couple of sellers who have notified, they've seen that I haven't acknowledged receipt, and they have proactively extended the protection period and said, we'll give you like an extra 30 days. And there are a couple of orders that have been getting close to the protection period running out, and I have gone into AliExpress and said, and requested an extension of the protection period, and then that's been granted. But I think we're going to be having some difficulties over the next couple of months because there are going to be so many orders that just vanish, and getting refunds and things could be a real problem. Difficult. Ooh, here is a challenge from Aaron. Aaron Knox said, programmable breadboard, which you can program traces. The breadboard holes have a backlit LED that visualizes the program traces. Challenge. That sounds complicated. At that point, you're almost into a circuit simulator. Oh, and Jim said, do you guys have Mother's Day down under? Yes, we do, and it is Mother's Day today. However, we also have social isolation. Well, I still don't like that term. I think it should be physical distancing, not social distancing, because we want to stay socially connected like this, even when we are physically isolated. And so technically we do. The restrictions have been relaxed a little bit in most states around Australia. Today, I think, is when most of them were relaxed, but not in Victoria. Victoria is possibly going to be in the next couple of days. So right now in Victoria, we're not meant to go and see people. But in other states, I think there are certain things where you're allowed to go and visit your mum, as long as no one else is visiting her at the same time, and there are certain limitations. Oh, wow, I've just discovered that there is so much extra in the chat that I've missed. Okay, oh, here's an interesting comment from Tradie Trev. Check out Scanlime. She converted an old electronic game, Robot Odyssey Rewired. It was interesting her telling us that she learnt, telling us how she learnt electronic logic. Yeah, that is cool. I'm definitely going to check that out. So I've seen some of Scanlime's videos, but I haven't specifically seen that. So I'm going to go and look for that one and see the explanation. Alrighty. Oh, Stefan said it's now 3:42 in Sweden. Time to sleep. Well, thanks for hanging in there, Stefan. Okay, so Ecognito3 said, I did the RDT course. So RDT is Robotics and Digital Technology at Chisholm 2. Changed to Monash at the start of my second year. I also still have a couple of those VT100s. At the start of your second year, you might have been there at the exact same time. Well, you would have definitely been there at the same time as me. Maybe even in the same year. I don't know. So when I started, it was called Chisholm, and then I think it might have been at the start of my second year, it became Monash. That would be bizarre, because that course is not very big. I think from memory there were maybe 70 or 100 people in it, something like that. So Ecognito 3, we might have been sitting near each other in the digital logic class or in the programming class or something. Yes, so I have a very annoying story from that class, and the guy who was head of... I'm going to try not to go off on a tangent, but I ended up not finishing that course. I left, and I already had my own business at the time. I was doing automotive electronics. I had a business called Rotor Systems Design, or RSR, and I used to do devices for things like engine management and safety devices for race cars and things. So I ended up leaving like in second year, essentially. I never actually finished my degree. And part of that was because of a big argument that I had with the guy who was head of the course. I may have even told that story way back in the past. A guy who told me I had no understanding of electronics, no aptitude for it, and I would never be able to do it. Unexpected maker. Question for Aussies. Total sidetrack. Anyone have a supplier for plastic or nylon M2.5 standoffs? No, not kits, but bags of standoffs. I'm just highlighting that question in case anybody else can give Sion an answer on that one. For that sort of thing, I normally find someone cheap on AliExpress and wait a month for stuff to arrive. But that's a bit of a problem right now, so I don't really have an answer to it. But if someone has a supplier of standoffs for Sion, the unexpected maker, please speak up. Oh, Guru says, I've gotten refunds from all 4 that didn't get here without issue from AliExpress. That's good to hear. Alright. Jim Amos said, has anyone got a shipment from China lately? I have 2 AliExpress orders that have languished in China, going on 30 days and longer. I currently have... I've actually got a spreadsheet of it because I do so many orders that I have a spreadsheet where I record. In fact, just for the hell of it, let's see if I can find it. I'm going to pull it up. Let's see what orders I currently have in flight. Well, not necessarily in flight, but in progress from AliExpress. I will switch my video view to it once I've got the right document open, because I've got a whole bunch of other stuff here in Google Docs as well. Alright, so this is my spreadsheet of AliExpress orders. Where is my desktop? There it is. Well, this is one of them. I've got a spreadsheet for Freetronics parts orders, and I've got a spreadsheet for SuperHouse parts orders. And this isn't just AliExpress. There are eBay orders and other things here as well. So you can see if I scroll back and back and back and back. Oh, there's some Banggood orders, some more AliExpress orders. It just keeps going and going. So these are all different things that I've ordered from mostly AliExpress over the years. You can see it starts back here, February 2016 was the first order, so 558 lines back in the spreadsheet, minus a few blank ones at the top. And so I've got a record of when I ordered it, and then I've got the date of when it arrived, and then there is an auto calculation for how many days it took in transit, whether it's arrived, the URL of the original seller, what it was, and how many I ordered, the unit price, whether it's got GST involved. So if we scroll way back up to the top now, I've got 700 screw terminals that I ordered only a couple of days ago. God knows when those are going to actually go anywhere. Normally, things like this would have arrived well by now. Look here, back in 25th of February, I ordered some resistors, 47K, 120R, 22R, and 5.1K. They were reels of 0603, 5,000 pieces each, and they still have not arrived. Back from 25th of February. So who knows what's happened with that order. I've got mini drill chuck, charger modules, nylon spacers, crystals. So these crystals I've been waiting on since 19th of March. And I could actually really do with these 12 megahertz crystals. USB cables, nuts and bolts. I've got some hardware coming. This spring steel battery clip is for my Ryobi battery system project, which I've mentioned in the past on, I think on Twitter or Facebook or somewhere. That was part of doing a power supply for a ventilator. So like a medical power supply that uses easily available power tool batteries for backup purposes and other bits. So you can see here that I've got some that arrived. So this one arrived 10th of April and nothing has arrived since then. Right? Yeah, looks like it. And it's all over the place. So this one way back here arrived on 8th of April and it took 41 days to arrive. This, oh no, that one was on eBay, so that wasn't even from AliExpress. 9th of April, I got some parts from AliExpress that had taken 20 days to arrive. So that is actually pretty impressive. 20-day transit on, it would have been ePacket or some economy service like that. And that was ordered 20th of March, so that was well into when all of the chaos was underway, and it still arrived in 20 days. But then there are others ordered way back, and who knows. So it's a bit of a random thing right now. Don't really know what is going on. The comment I fell on was Tradie Trev saying my mum's blender broke. I tried to fix it, but it ended up in flames. Instructions unclear. My toaster became a microwave. Yeah, that can happen. Yep, and Scott made the comment, keep careful track of your AliExpress protection periods, folks. Definitely. Yeah, and James said, I'm up on 2 months now for some stuff from China. Yeah, and it's not just stuff from China. It's, from what I can see, China is now back in pretty good shape internally. The issue is with international transit, lack of flights, and it's other countries not accepting things. So when a package is outbound from China, there is a customs pre-clearance that is lodged by the Chinese Postal Service with the destination country, and at the moment most countries just aren't accepting packages. I've had a number of customers that I shipped packages to internationally just before I turned off international shipping for my own, for Freetronics and for SuperHouse. And I had one who just a couple of days ago said that he received his package that was ordered a few weeks ago. and so this was in the US, and it seemed to arrive. It was delayed. It took a little bit longer than a package would normally take from Australia to the US, but it did get there. So I think some things are making it through, but it's just so unpredictable. It's all over the place. All right. Yeah, Ecognito said, I have an eBay order from Shenzhen, ordered April 28th, which is sitting in Dandenong, will arrive Monday to Wednesday this week, according to Ozpost tracking. Yep. Dev45 says, bedtime here in Ontario, Canada. In nice, sunny Ontario. And Byrne says, good night, thanks for your company. So thank you. I'm going to wrap it up now. It's been a couple of hours, and thank you all for hanging in on this fine Sunday or Saturday night or whatever it happens to be. Oh, Mike Conti just said, hey guys, missed the show. No. I'll do another one again next week, Mike. You can come along. If you want to continue conversations, make sure you jump on Discord. superhouse.tv/Discord will get you to an invite. Invitations are open, so you can jump on and chat about stuff. And while I'm on the subject of Discord, I should point out Unexpected Maker also has his own Discord, and there are some other Discords. If you want to chat about different electronic-y type things, there are a few good ones around. Oh, hi yours. Sion said yours just walked in and said hi. And Keith, hey, 3 a.m. in Ireland. Thank you for joining us. Scott said post the link again. Okay, so I should have put this in my clipboard earlier. It's amazing how difficult it is typing sideways. The keyboard, because I'm using the camera sitting off to the side right now, my computer is actually oriented that way. It's when I'm typing on sideways, and it really screws me up. David said A-grade rambling. Yeah, I do that a bit. Okay, thanks everyone. I hope you have a great Mother's Day, and I will see you very soon, either on Discord or the live stream next week. So thank you, and good morning and good night. If I can work out how to switch this back to ending. Where is the end? There.